close your eyes. Imagine a weight. Not the weight of your body on your bed, but the weight of a life no heavier than a coin. A tiny European robin, barely 18 grams of feathers and bone, perched on a frost-covered branch in a darkening Siberian forest. For thousands of years, we watched them disappear. We watched the sky fill with a silent, feathered river, and we had no name for where they went. Aristotle, the great philosopher of ancient Greece, looked at these birds and could not fathom their journey. He proposed a theory of transmutation. He believed that the red starts of summer simply transformed into the robins of winter. To the ancient mind, it was more logical to believe a bird could change its very essence than to believe it could navigate across the curve of the earth, over trackless oceans and shifting sands, to find a single, specific tree in a forest 3,000 miles away. As you breathe in, consider the sheer impossibility of this feat. This is not just a journey, it is a miracle of precision. A journey of 5,000 miles, with an error margin of less than a single degree. If you were lost in the middle of the Atlantic, with no stars and no sun, how would you find your way home? You would feel the void. But the bird feels a pull, a tug from the very core of our planet. For decades, science tried to explain away this magic. We looked for the obvious. First, we proposed solar navigation. We thought perhaps they were masters of the sun's arc. But then came the storms, the clouds that blanket the earth for weeks. The birds flew on, undeterred, their internal maps unshaken by the gray veil above. Then, we looked to the stars. Stellar navigation. We placed birds in planetariums and rotated the constellations. Yes, they could read the stars, but what of the rainy nights? What of the fogs that swallow the horizon? The birds did not stop. We even considered olfactory navigation, a map made of scents. We thought perhaps they smelled the salt of the Mediterranean or the cedar of the Atlas Mountains. We blocked their nasal passages, we disrupted their sense of smell, and yet they arrived. On time, at the exact coordinate. Every classical explanation fell short. It was as if the birds were listening to a broadcast we couldn't hear, or reading a script written in a language we hadn't yet discovered. We were looking for a mechanical solution to a mystery that was beginning to look ethereal. The year was 1972. Wolfgang and Roswitha Wilczko, a husband and wife team of scientists in Frankfurt, decided to challenge the Earth itself. They built what is now known as the Wilczko cage, a device that could manipulate the magnetic field around a bird. They placed a robin inside an Emlyn funnel, a small enclosure lined with ink pads. As the bird tried to fly north, its feet would leave ink marks, showing its intended direction. When they changed the magnetic field, the bird changed its direction. This was the proof. Birds could feel the Earth's magnetism. But then came the discovery that would haunt biology for 30 years. They found that this magnetic sense only worked under specific colors of light. If the room was bathed in red light, the bird became blind to the magnetic field. It would hop aimlessly, lost in its own cage. But the moment the light was shifted to blue or green, the bird's internal compass snapped back into alignment. Think about that for a moment. As you drift deeper into relaxation. A mechanical needle doesn't care if the sun is red or blue. A magnet works in total darkness. This was the first hint that the bird's compass wasn't a piece of metal. It was a piece of biology that responded to light. It was a compass that needed to be ignited. The hunt was on for the hardware. Scientists searched for iron. They looked for tiny crystals of magnetite in the beaks of birds, thinking they would find a literal needle in a haystack. They found iron, yes, but it was in the immune cells. It had nothing to do with navigation. The iron compass was a dead end. Then, in the year 2000, a physicist named Klaus Schulten proposed a hypothesis so radical it sounded like science fiction. He suggested that the compass wasn't in the beak, but in the eye. He pointed to a protein called cryptochrome. This protein sits in the retina of the bird. It is an ancient protein found in plants and animals alike, used to regulate circadian rhythms, the body's internal clock. Schulten argued that when a single photon of blue light enters the bird's eye and hits a cryptochrome molecule, it triggers a chemical reaction that is so sensitive, so fragile, that it can be influenced by the Earth's magnetic field. A field so weak, it can barely move a paperclip. The conclusion was staggering. Birds do not hear the magnetic field. They do not smell it. They see it. It is an augmented reality overlaying the physical world. A shimmer of light and shadow that tells them where the poles lie. But how? How can a protein in a warm, wet, vibrating eye detect a magnetic field that is 100 times weaker than a common refrigerator magnet? This is where the story leaves the world of the large and enters the world of the impossibly small. To understand the bird's eye, we must leave the forest. We must leave the feathers and the wind behind. We must go down, past the cells, past the molecules, to the electrons themselves. We must enter the world of quantum entanglement, the world where two particles are linked across space, dancing in a rhythm that defies time itself. Imagine for a moment that you are not merely watching the bird, but inhabiting its consciousness. As you drift closer to sleep, let the boundaries of your human senses dissolve. For a migratory bird, the world is not a simple map of mountains and rivers. It is a multi-layered tapestry of energy. When a bird takes flight at twilight, it is navigating through a symphony of forces. It feels the barometric pressure change against its feathers, sensing the weight of the air itself. It hears the infrasound, the ultra-low frequency thrum of the distant ocean surf, a sound that can travel thousands of miles through the atmosphere. But dominant over all of this is the magnetoreception. To the bird, the Earth's magnetic field might look like a soft, translucent fog of light, shifting in intensity as they tilt their heads. In the northern hemisphere, the lines of force dive steeply into the soil. At the equator, they run parallel to the horizon. This isn't just a compass. It's an inclination compass. They don't just know where north is. They know exactly how far they are from the pole by the angle of the invisible threads pulling at their retinas. As you breathe slowly, imagine this augmented reality. Every flap of the wing is a movement through a sea of magnetism. The bird isn't lost in the dark. It is swimming through a glowing geometric blueprint of the planet. Now, let us zoom in, far past the feathers, past the skin, into the damp, dark chamber of the avian eye. Here lies the hero of our story, Cryptochrome 4. For millions of years, evolution has been a master watchmaker, and cryptochrome is its finest gear. This protein was not originally meant for navigation. In the ancient ancestors of birds, and even in the plants that grow in your garden, cryptochrome was a timekeeper. Its job was to sense the blue light of dawn and reset the biological clock. But in the migratory bird, evolution did something audacious. It took this clock and turned it into a sensor. It placed these proteins in a highly organized lattice across the retina, like the pixels on a high-definition camera. When that single blue photon we discussed earlier, a tiny packet of energy from the morning sky strikes this protein, it kicks an electron away from its home. This is the chemical spark. For a billionth of a second, the protein enters a state of high-energy tension. It is in this fleeting moment of chemical instability that the Earth's magnetic field, a force so weak it cannot turn a page of a book, can tip the scales. Think of a pencil balanced perfectly on its tip. A tiny breath of wind determines which way it falls. Cryptochrome is that pencil. The magnetic field is that breath. And the direction the pencil falls determines the message sent to the bird's brain. You are on course. Hold the line. The journey to this discovery was a war of ideas that lasted 40 years. On one side stood the mineralists. They believed biology was mechanical. They found magnetite, tiny magnetic iron crystals in the beaks of pigeons. It made sense. It was a physical needle. The mineralists spent the 1,980 seconds and 90 seconds mapping the nerves of the beak, convinced they would find the compass nerve. They published papers in the world's most prestigious journals. They were certain. But then came the anomalies. If the compass was in the beak, why did the birds need blue light to see the field? Why did numbing the beak's nerves have zero effect on their ability to find north? The mineralist theory began to bleed out. In a series of dramatic experiments in the early 2000s, researchers used high-resolution imaging to prove that the iron crystals in the beak weren't sensors at all. They were actually white blood cells cleanup crews of the immune system that just happened to contain iron. It was a humbling moment for science. We had spent 20 years looking at a waste bin and calling it a GPS. The real GPS was far more ghost-like. It wasn't a solid crystal. It was a quantum flicker in the eye. This shift from mechanical biology to quantum biology is what transformed our understanding of life itself. We realized that life doesn't just use chemistry. It uses the fundamental spooky laws of the universe to survive. As you sink deeper into your pillow, imagine a bird that refuses to let the sun set. This is the Arctic tern Sterna paradisea. While the godwit is a master of the sprint, the tern is the master of the marathon. It is a creature of the in-between, a bird that lives in a state of perpetual daylight, chasing the sun across the longitudinal lines of our planet. Every year, this bird, weighing no more than a small handset, performs a journey that defies human imagination. It breeds in the high Arctic, under the midnight sun of the North Pole, but as the first hint of autumn chills the air, it does not merely fly south. It embarks on a jagged, zigzagging Odyssey that takes it all the way to the pack ice of Antarctica. Over its lifetime, a single Arctic tern will fly a distance equivalent to 3 round trips to the moon. Think of the sheer volume of data passing through that tiny, quantum-sensitive eye. For 90,000 kilometers a year, it is reading the Earth's magnetic signature. It is a quantum cartographer, mapping the invisible valleys and peaks of the magnetic field over the deepest trenches of the ocean. In this state of constant motion, the bird becomes a bridge between the poles. As you breathe, imagine the transition from the sharp, crystalline blues of the Arctic to the humid, heavy air of the tropics, and finally back to the silent, white expanse of the south. The tern is never truly home. Its home is the quantum highway itself. But the journey is not a straight line. The magnetic field of the Earth is not a perfect grid. It has dead zones, anomalies where the iron in the Earth's crust twists the signal, and areas near the magnetic equator where the lines of force run so flat they are almost impossible to read. How does the tern survive these moments of magnetic silence? This is where the expansion of the brain meets the precision of the eye. Scientists believe the bird possesses a form of internal cinema. When the magnetic signal grows weak or confusing, the bird switches its sensory priority. It begins to rely on polarized light navigation. As the sun sets or rises, the light in the sky is polarized. It vibrates in specific directions. To our human eyes, the sky is just blue. But to the tern, the sky is etched with a polarized pattern, a giant celestial compass that remains visible even when the sun is behind a cloud. Imagine being able to see the vibration of light itself. As you drift off, visualize the tern's vision, a world where the sky is a shimmering architecture of lines, and the ocean below is a map of magnetic shadows. It is never truly dark for the voyager. The universe provides a backup system for every mile. When the quantum compass in the eye flickers in a dead zone, the polarized light of the atmosphere takes the lead. It is a redundant, fail-safe system designed by 3 billion years of evolution. For centuries, we used the term bird brain as an insult, a way to describe something small, simple, and reactive. But as we peel back the layers of the tern's journey, we realize we were looking through the wrong end of the telescope. The brain of a bird is a masterpiece of spatial compression. While our massive human brains are busy with language, anxiety, and abstract thought, the bird's brain is a dedicated, high-speed quantum processor. During migration, the bird enters a state called unihemispheric slow-wave sleep. They sleep with half of their brain at a time. One eye remains open, scanning the horizon, reading the magnetic field, while the other half of the brain rests. They are dreaming while they are flying. Think about the poetry of that state. As you yourself move toward sleep, imagine you are like the tern. Part of you is drifting into the deep, dark waters of the subconscious, while another part of you remains online, anchored to the rhythm of your breath, just as the bird is anchored to the magnetic pulse of the earth. The bird brain is not small. It is efficient. It has mastered the art of being everywhere at once, in the sky, in the dream, and in the quantum field. It is a biological computer that operates on the scale of atoms, yet navigates on the scale of planets. To fill the silence of the long flight, the tern also listens to the global hum. We call this infrasound. These are sounds below the threshold of human hearing. The deep, guttural roar of the Atlantic swell hitting the cliffs of Africa, the groan of the shifting tectonic plates. These sounds create an acoustic map that stretches for thousands of miles. The bird hears the mountain ranges before it sees them. It hears the storm brewing 2 days away. Combined with the quantum sight in its eye, the bird exists in a world of hypersensory clarity. As the tern crosses the equator, the quantum compasses must reset. The polarity of the world flips. What was down becomes up. In that moment of transition, the bird doesn't panic. It pauses, it recalibrates, and it trusts the flicker in its cryptochrome. As we conclude this expansion of the first chapter, let the image of the tern be your guide. A creature that trusts the invisible. A creature that sees the light in the dark. A creature that is never lost because it is always connected to the heartbeat of the world. This brings us to one of the most famous red herrings in the history of science, the story of the magnetite in the beak. For over 30 years, the homing pigeon was the poster child for the mechanical compass theory. In the late 20th century, researchers discovered tiny, iron-rich clusters in the skin of the pigeon's upper beak. The scientific world celebrated. They thought they had found the micromagnet. They believed these crystals were connected to the trigeminal nerve, sending magnetic pings to the brain every time the bird turned its head. It was a beautiful, simple, mechanical explanation. It was the iron compass. But science is a process of brutal refinement. In 2012, a team of researchers decided to look closer, not just at the iron, but at the cells themselves. What they found was a shock that sent ripples through the biology departments of the world. These iron sensors weren't neurons at all. They were macrophages' immune cells that simply happened to store iron as a byproduct of recycling old red blood cells. Imagine the silence in the lab when they realized their GPS was actually a recycling bin. It was a moment of profound humility. We had been looking for a physical needle, but the bird was using something far more sophisticated. The pigeon wasn't feeling the pull of iron. It was reading the quantum dance of light in its eyes, just like the tern, but with a resolution tailored for the complexity of the landscape. This leads us to a modern crisis: the electromagnetic fog. Our cities are no longer just made of stone and glass. They are saturated with invisible noise Wi-Fi signals, cellular towers, high-voltage power lines. For a quantum-sensitive creature, this is like trying to hear a whisper in a hurricane. This is where the pigeon's urban navigation becomes a story of resilience. Scientists have found that man-made radio frequency noise, the kind emitted by our everyday electronics, actually disrupts the cryptochrome reaction in the bird's eye. It causes the quantum compasses to flicker and fail. Yet, the pigeons still find their way. How? They use a multimodal backup system. When the quantum grid becomes too noisy, the pigeon's brain performs a high-speed sensory handover. It switches to infrasound, mapping the low-frequency signature of the city's geography and its legendary olfactory map. Yes, the pigeon can smell its way home, creating a mental map of scents that drift on the wind. Think of the complexity of that internal world. While you lie here, safe from the noise of the world, the pigeon is filtering through 1,000 signals, searching for that one true quantum north that survives the static of the modern age. It is a master of information sifting, a biological processor that never sleeps. Why does the story of the homing pigeon move us so deeply? Perhaps it is because, in our own subconscious, we also possess a homing pulse. Ancient human cultures spoke of songlines and wayfinding, a sense of direction that didn't rely on maps, but on a deep, intuitive connection to the land. By studying the pigeon's quantum eye, we are actually studying a part of ourselves that we have forgotten. The cryptochrome protein found in birds is also present in the human retina. While we may have lost the ability to consciously see the magnetic field, the hardware is still there, a ghost in our own biology. As you drift towards sleep, imagine that your own internal compass is resetting. Like the pigeon released into the unknown, your mind is finding its way back to its center, back to its home. The quantum world isn't just out there in the sky. It is in the very cells of your eyes, a silent, ancient guide that has been with us since the dawn of life. As you drift deeper into the stillness of the night, let us travel back in time to the early 20th century. Before we had high-resolution microscopes or quantum computers, we had only the power of observation and the courage of the heretic. For a long time, the idea that animals could sense the Earth's magnetic field was treated not as science, but as occultism. In the 1850 seconds, a Russian naturalist named Alexander von Middendorf noticed that the flight paths of birds across the Siberian tundra were suspiciously aligned with the magnetic poles. He published his findings, suggesting that birds might be living compasses. The scientific establishment of the Victorian era laughed. To them, the world was mechanical, made of steam, gears, and measurable forces. The idea that a soft, biological brain could interact with the invisible, ghostly lines of the planet's magnetic field was seen as vitalism, a primitive belief in magical life forces. Middendorf's observations were dismissed as mere coincidence, and for nearly a century, the study of magnetoreception was relegated to the fringes of academia, a dark corner inhabited only by those willing to risk their reputations on a mystery that no one could prove. Fast forward to the late 1960 seconds. The world was focused on the space race, on landing men on the moon. Yet in a small laboratory in Frankfurt, Germany, a different kind of frontier was being explored. Wolfgang Wiltschko, then a young researcher, decided to revisit the bird compass mystery. He didn't have the backing of major government grants. He had something more powerful, a relentless, quiet patience. He was joined by his wife, Roswitha Wiltschko, and together they began a partnership that would last over 50 years. Their laboratory was a place of monastic devotion. Imagine the scene. Long, quiet nights in a basement, shielded from the electromagnetic noise of the city. The air was cool, smelling faintly of ink and paper. The Wiltschkos would sit in the darkness, lit only by a faint, dim light, watching the tiny European robins. This was the era of the Emlyn funnel. To the outside observer, it looked like a simple arts and crafts project, a cone of blotting paper with an ink pad at the base. But to the Wiltschkos, it was a window into the mind of a traveler. Every tiny scratch of the bird's feet on that paper was a word in a hidden language. They were the first to demonstrate with cold, hard data that the birds were indeed orienting themselves to the magnetic north. But when they presented their findings, they weren't met with applause. They were met with a wall of skepticism. Critics argued that the birds were simply responding to the tilt of the cage, or the smell of the lab, or the subtle vibrations of the floor. The Wilczkos were accused of seeing what they wanted to see. They were under a scientific siege. To prove their theory, they had to isolate the compass. They had to prove that if you changed the magnetic field, the bird's internal world changed with it. They worked for years in near obscurity, amassing thousands upon thousands of paper cones, until the evidence became an undeniable mountain. They proved that the compass was real, but they were left with a question that would take another 30 years to answer. How does a creature made of flesh feel a field made of ghost? As the Wilczkos were mapping the behavior, the world of physics was undergoing its own chaotic revolution. In the 1970 seconds, a young German physicist named Klaus Schulten was working on something that seemed entirely unrelated to birds: the behavior of fast-moving electrons in chemical reactions. Schulten was a man of the New Age, a scientist who saw the world through the lens of quantum mechanics, the strange, non-intuitive rules that govern the very small. In 1978, Schulten had a eureka moment that was so radical he hesitated to publish it. He realized that certain chemical reactions involving radical pairs of electrons born in a state of quantum entanglement, were incredibly sensitive to magnetic fields. He knew that the Earth's magnetic field was weak, but he saw that at the quantum level, even a whisper of energy could flip the spin of an electron, changing the entire outcome of a chemical reaction. He sat back in his chair and looked at a report on bird migration. He saw the blue light requirement discovered by the Wilczkos, and the pieces clicked together. He hypothesized that birds weren't using a mechanical needle. They were using a quantum sensor. They were seeing the result of a chemical reaction that happened so fast it defied classical physics. When Schulten first proposed this in a short, dense paper, the world ignored him. It was too spooky. Biologists didn't know quantum physics, and physicists didn't care about birds. Schulten's idea sat like a dormant seed in the soil of science for over 20 years. He was the pioneer who built the bridge, but he had to wait for technology to catch up to prove that the quantum ghost he saw in his equations was actually living in the eye of a robin. Behind these famous names were hundreds of graduate students and technicians who spent their youth in darkened rooms. We must remember the ink scrapers, the students who had to manually count the thousands of tiny dots on the Wilczkos paper cones. This was a science built on the labor of the eyes and the spirit. They were the ones who noticed the tiny anomalies, the bird that failed to navigate when a radio was turned on nearby, or the way the compass seemed to reset after a storm. These pioneers were not just looking for a bird's direction. They were fighting for a new way to see life. They were challenging the idea that biology is just wet engineering. They were suggesting that life is a delicate, exquisite performance of the most fundamental laws of the universe. As you move toward sleep, think of this historical lineage, a chain of thinkers reaching back through the centuries, all pulled by the same invisible north, all trying to understand why we and the birds feel the need to find our way home. As you settle into the profound quiet of this journey, consider the seductive power of a simple idea. In the 1970 seconds and 80 seconds, biology was deeply in love with the mechanical. We had discovered the double helix of DNA. We were mapping the clockwork of the cell. And so, when we looked for a bird's compass, we wanted something we could touch. We wanted an object. This gave birth to the magnetite hypothesis, a theory so elegant and so intuitive that it nearly blinded the entire scientific community for 30 years. The idea was simple. If a ship uses a needle made of iron to find the north, why wouldn't a bird? The hunt for the biological magnet became the gold rush of the late 20th century. Scientists across the globe began disassembling the anatomy of pigeons with the fervor of watchmakers looking for a hidden spring. And then they found it, or so they thought. In the upper beak of the homing pigeon, researchers identified tiny, dark clusters of iron-rich crystals, magnetite. The headlines of the day were triumphant. "The secret of the pigeon found," they proclaimed. It was the perfect story. A tiny, built-in GPS made of the very same material used by ancient mariners. But as we shall see, nature has a wicked sense of humor, and science is often the butt of the joke. For the next 2 decades, the beak compass was the undisputed king of the field. It was taught in textbooks. It was cited in thousands of papers. But there was a growing, awkward silence in the laboratory. If the beak was the compass, why did the birds need blue light to navigate? Why did they lose their way if you covered their eyes, even though their beaks were perfectly exposed to the magnetic field? This period of scientific history is a fascinating study in what we call confirmation bias. We so badly wanted the compass to be a piece of iron that we ignored the ghost in the room. Scientists spent years trying to find the nerves that connected the beak to the brain. They would stimulate the beak and look for a spark in the neurons. Sometimes they thought they found it. Other times, the results were inconclusive, a scientific euphemism for "it's not working, but I'm too embarrassed to say so." Imagine the frustration of a generation of PhD students sitting in windowless rooms, trying to prove a connection that didn't exist. They were looking for a telephone wire in a world that was already moving toward wireless quantum communication. They were dissecting the hardware, never realizing the software was running on light. This 20-year detour cost millions of dollars and countless hours of sleep. But it was necessary. In science, sometimes you have to exhaust every wrong door before you're willing to look at the one that's glowing in the dark. The climax of this comedy of errors came in 2012 in a paper that felt like a bucket of cold water to the face of the biological world. A group of researchers in Vienna decided to take a much closer look at those iron sensors in the pigeon's beak. They didn't just use a microscope. They used high-resolution imaging that could see the individual molecules within the cells. Those tiny clusters of magnetite weren't connected to the nervous system at all. They weren't sensors. They were macrophages. To put this in perspective, imagine a group of detectives spending 30 years studying a high-tech surveillance camera at the scene of a crime, only to realize it was actually a discarded soda can that just happened to be shiny. Macrophages are the trash collectors of the immune system. Their job is to eat old red blood cells and recycle the iron. The iron compass wasn't a sophisticated GPS. It was just a collection of microscopic iron scrap heaps. The beak compass theory didn't just fall, it evaporated. It was one of the most spectacular oops moments in modern biology, and it left the throne empty. If the iron was a lie, then the blue light and the cryptochrome were no longer just fringe theories. The stage was finally set for the weird, the spooky, and the quantum. As the Iron Age of magnetoreception died, a new, more mysterious era began. But the transition wasn't easy. Biologists are, by nature, people of the wet and warm. They like things they can stain with dye and see under a lens. Quantum physicists, on the other hand, are people of the cold and dry. They deal with things that exist in multiple places at once and vanish the moment you look at them. The marriage of these two worlds was like a shotgun wedding between a gardener and a ghost hunter. The biologists didn't want to believe that a bird's survival depended on a radical pair of electrons that only existed for a millionth of a second. It felt too fragile, too magical. They argued that the thermal noise of a living body, the constant vibration of molecules, would destroy any quantum state instantly. "It's too hot for quantum," they shouted. But the birds didn't care about the shouting. They kept flying. They kept crossing oceans. They were living proof that nature had solved a problem that human engineers are still struggling with today: how to keep a quantum state alive in a messy, warm, vibrating environment. The story of the pioneers is ultimately a story of humility. The moment we realized that a common robin has been doing quantum computing in its eye for millions of years, while we were still trying to figure out how to use a magnet. As you drift deeper into the soft embrace of the night, we must leave behind the world of things you can touch, see, and measure with a ruler. For centuries, humanity lived in what we call the Newtonian universe. It was a world of absolute certainty, a giant, celestial clockwork where every cause had a predictable effect. If you knew the position and velocity of every atom, you could, in theory, predict the entire future of the cosmos. It was a comforting world. It was a solid world. But at the dawn of the 20th century, this clockwork began to crack. Scientists like Max Planck and Niels Bohr started peering into the heart of the atom, and what they found wasn't a miniature solar system of solid balls. They found a ghost world. They found that at the most fundamental level, the universe isn't made of stuff. It is made of probabilities. An electron isn't here or there until you look at it. It exists in a shimmering haze of everywhere at once. This was the first great shock to the human ego. We realized that our senses, which tell us the world is solid and stable, are lying to us. The floor beneath your feet, the bed you are lying on at the atomic level, they are mostly empty space, held together by invisible forces that defy common sense. As you breathe slowly, imagine the solid world dissolving into a sea of vibrating energy. This is the stage where the bird's compass actually operates not in the world of the beak and the bone, but in the world of the quantum flicker. The most unsettling discovery of this new physics was something that even Albert Einstein couldn't stomach. In 1935, Einstein, along with his colleagues Boris Podolsky and Nathan Rosen, published a paper that would become a legend in the history of thought. It is known as the EPR paradox. Einstein was a man of reality. He believed that things existed independently of our observation. He famously asked, "Do you really believe the moon is not there when you are not looking at it?" But the equations of quantum mechanics suggested something far more disturbing: quantum entanglement. The math showed that two particles, once they have interacted, become entangled. They share a single existence. If you take these two particles and separate them, put one in your room and the other on the far side of the Andromeda galaxy, they remain linked. If you change the spin of one particle, the other changes its spin instantaneously. Einstein called this spooky action at a distance, spookhafte Fernwirkung. He hated it. He argued that it violated the ultimate speed limit of the universe, the speed of light. He believed that quantum mechanics must be incomplete, that there must be some hidden variables we hadn't found yet. He spent the rest of his life trying to prove that the universe wasn't this weird. But as you drift towards sleep, know this: the greatest mind of the 20th century was wrong. The ghost was real, and it was eventually going to be found in the eye of a common robin. For decades, the debate between Einstein and Niels Bohr remained a philosophical one, a he said, she said of the physics world. That changed in the 1960 seconds with a quiet, soft-spoken Irishman named John Bell. Bell wasn't interested in philosophy. He wanted a mathematical way to settle the score. He devised what is now called Bell's inequality. It was a brilliant, elegant way to test if Einstein's hidden variables existed, or if the universe was truly as spooky as Bohr claimed. It took years of experimental refinement, but in the 1980 seconds, Alain Aspect in France conducted the definitive test. The result was a thunderclap. Einstein was wrong. There are no hidden variables. The particles really are connected across space, in a way that defies our understanding of time and distance. This wasn't just a quirk of math. It was a fundamental law of reality. Two things can be one, even when they are miles apart. Think about the implications for the bird. When we talk about quantum navigation, we aren't using a metaphor. We are talking about the fact that inside the bird's eye, pairs of electrons are born in this exact state of spooky connection. They are dancing to the rhythm of a physics that Einstein found terrifying, but that a bird finds essential for survival. Now, we encounter the great mystery that makes the bird's eye even more incredible. In a physics lab, creating quantum entanglement is a nightmare. You need a vacuum colder than deep space. You need to shield the particles from every vibration, every stray photon, every whisper of heat. If anything touches the entangled particles, the ghost vanishes. We call this decoherence. It is the reason we don't have stable quantum computers in our pockets yet. And yet, here is a robin. It is warm, about 40 degrees Celsius. It is wet. It is vibrating with the beating of a heart and the flapping of wings. By all the laws of human physics, quantum entanglement should be impossible in such an environment. It should collapse in a billionth of a second. This is the $1.5 trillion question of modern science. How does life protect the ghost? How has evolution built a quantum shield inside a living cell? Scientists now believe that the very structure of the cryptochrome protein is designed to act as a quantum cage. It holds the entangled electrons in a specific geometric arrangement that wards off the noise of the warm body just long enough, a few microseconds for the day, Earth's magnetic field, to leave its mark. As you lie in your own warm bed, consider the sophistication of your own biology. You are a walking, breathing miracle of quantum engineering, a warm and wet machine that maintains the most delicate states of the universe within your own cells. As you breathe in the stillness of the night, let us leave the grand history of Einstein and Bohr behind. We are shrinking now, past the feathers of the robin, past the moist surface of its cornea, deep into the liquid forest of its retina. We are searching for a single molecule of cryptochrome 4, anchored like a silent sentinel in the light-sensitive cells of the bird's eye. Imagine this molecule as a complex, interlocking cathedral of atoms. At its heart sits a light-absorbing chromophore, a tiny trap designed to catch a single grain of blue light. This is where the radical pair mechanism begins. It is the bridge between the world we know and the ghost world we fear. The moment arrives. A single blue photon, traveling from the morning sky, strikes the cryptochrome molecule. This isn't a gentle nudge. It's a precise, high-energy impact. In an instant, an electron, a tiny, negative charge, is kicked out of its comfortable home. It leaps across a gap within the protein, leaving behind a hole. Now, we have two radicals. These are atoms, or molecules, with an unpaired electron, making them chemically restless and highly reactive. But these two electrons are not strangers. They are the twins. Because they were born from the same event, they are quantumly entangled. Even as they move apart within the protein, they are linked by an invisible subatomic thread. They are like two dancers on opposite sides of a stage, separated by a distance that, in their world, is vast, yet moving in a perfect, eerie synchronicity. As you lie still, imagine this birth, the spark of blue light, creating a connection that defies the boundaries of space. Now, the dance begins. Every electron has a property called spin. Do not imagine a ball spinning on an axis. Imagine a tiny, internal compass needle that can only point up or down. Because our twins are entangled, their spins are locked in a specific relationship. At the moment of their birth, they are usually in a singlet state. One points up, the other points down. They are perfectly balanced, canceling each other out, but they do not stay this way. Inside the bird's eye, they begin to precess. They wobble like spinning tops that are starting to lose their balance. They flicker back and forth between the single state opposing spins and the triplet state parallel spins. This flickering happens millions of times every second. It is a frantic, high-speed oscillation, a quantum heartbeat that is incredibly sensitive to its environment. This is the moment the Earth enters the eye. The Earth's magnetic field is incredibly weak. It is a ghostly whisper compared to the roar of the chemical forces inside the cell. Under normal circumstances, it should be ignored. But our entangled twins are in a state of radical suspense. Because they are flickering between singled and triplet states, the tiny tug of the Earth's magnetic field can change the timing of their dance. The magnetic field acts like a subtle, invisible choreographer, nudging the electrons to spend a fraction of a microsecond longer in one state than the other. The angle of the bird's head relative to the magnetic north determines the rhythm of this dance. If the bird tilts its head, the choreographer changes the beat. This is the miracle. A force from the center of the planet is reaching into a single protein in a bird's eye and altering the spin of two tiny electrons. How does the bird see this? The dance must eventually end. When the entangled twins finally settle back into a stable state, the chemical outcome depends on which state they were in at that final microsecond. If they were in the singlet state, the protein might trigger one chemical signal. If they were in the triplet state, it triggers another. This chemical message is then amplified, traveling down the optic nerve to a specialized area of the bird's brain known as cluster N. The bird doesn't see a needle. It doesn't see a number. It likely sees a shimmer, a shadow, or a bright spot superimposed on its visual field. In the direction of north, the shimmer might be darker. Toward the south, it might be brighter. For the bird, the magnetic field is not a hidden force, it is a color. It is a hue of the universe that we, in our blindness, have never seen. As you drift toward sleep, imagine the bird flying through the dawn. It sees the orange of the rising sun, the green of the forest, and the deep, pulsing blue of the north. It is guided by a dance of electrons that has been perfected over 300 million years, a quantum vision that turns the entire planet into a glowing, navigated map. Now, we must trace the journey of that fragile quantum signal as it leaves the retina and enters the dark, dense labyrinth of the avian brain. For a long time, we wondered where this magnetic image went. If the eye is the camera, where is the screen? Where is the processor that turns a flicker of electron spin into a life-saving map? The answer lies in a specialized, mysterious region of the bird's forebrain known as cluster N. This is not just a collection of neurons. It is a dedicated, high-speed biological computer that only fully boots up during the migration season. Imagine a dormant lighthouse that only begins to sweep its beam across the horizon when the seasons shift. Cluster N is a cluster of highly active cells that process visual information with a specific, singular focus. It is located at the very top of the bird's brain, and its activity is directly linked to the signals coming from the cryptochrome in the eye. But what makes Cluster N truly remarkable is its relationship with sleep and consciousness. During the grueling weeks of migration, a bird cannot afford the luxury of a full night's rest. It must fly through the dark, through the storms, and over the endless oceans. To survive, the bird's brain enters a state that challenges our very definition of what it means to be awake. Through a process called unihemispheric slow-wave sleep, the bird can shut down half of its brain to rest, while the other half, the half connected to cluster N, remains wide awake and hyper-vigilant. This means that as the bird flies, it is essentially dreaming with one eye and navigating with the other. Cluster N acts as a quantum bridge, maintaining the integrity of the magnetic map even as the bird's body is screaming with exhaustion. It takes the messy, noisy data of the chemical reaction in the eye and filters it, smoothing out the fluctuations of the Earth's magnetic field into a steady, reliable heading. Scientists believe that for the bird, this navigation isn't an intellectual task. It isn't thinking about where north is. Instead, Cluster N integrates the magnetic signal directly into the bird's visual reality. It is a form of synesthesia, a blending of the senses. Just as you might see a certain color when you hear a specific note of music, the bird sees the magnetic field as a visual texture. Imagine looking at a familiar landscape, but with a soft glowing grain of light that becomes denser as you turn toward the pole. This is the quantum HUD, a head-up display generated by Cluster N. It allows the bird to recognize the shape of the magnetic field just as easily as you recognize the shape of a house or a tree. As you drift toward sleep, consider the sheer processing power required for this feat. While the bird is buffeted by winds and its muscles are burning with effort, Cluster N is quietly, relentlessly calculating the angle of the Earth's dip. It is translating the spin of subatomic particles into a physical direction. It is the seat of the bird's genius, a tiny patch of gray matter that holds the secret to crossing the world. The mystery of Cluster N also reveals a profound truth about the evolution of the brain. It shows that nature can carve out entire regions of the mind to handle the spooky logic of the quantum world. It suggests that consciousness itself might be more flexible than we ever imagined, that it can accommodate senses that transcend the five we know. The bird in the sky is not just a creature of instinct. It is a creature of a higher quantum perception, guided by a brain that has learned to read the invisible ink of the universe. To understand the bird's journey, we must first understand the heartbeat of the Earth itself. As you sink deeper into your bed, imagine traveling downward, miles beneath the soil, past the tectonic plates, through the mantle of red-hot rock, until you reach the very center of our world. There, 3,000 miles beneath your feet, lies a spinning ball of molten iron and nickel, nearly as hot as the surface of the sun. This is the outer core, the churning, liquid engine of our planet. This sea of liquid metal is in constant, violent motion, driven by the intense heat of the Earth's inner core. Because iron is a conductor of electricity, this movement generates a massive electric current, which in turn creates a magnetic field. This is the geodynamo, a self-sustaining electromagnetic generator that has been running for billions of years. It is the reason our planet is alive. The magnetic field that guides the robin across the garden is the same field that stretches out tens of thousands of miles into space. It is a vast, invisible architecture of lines of force, erupting from the South Pole and curving gracefully back into the North Pole. It is a cradle of energy that surrounds the Earth, a silent guardian that never sleeps. Think about the scales of magnitude involved here. A single tiny electron in a bird's eye is responding to a force generated by a rotating ocean of liquid iron the size of Mars. This is the ultimate connection between the planetary and the subatomic. The bird is literally tethered to the molten heart of the world. As you breathe, imagine this connection, a thread of magnetic silk that binds the smallest living cells to the deepest, hottest fires of the Earth. The Earth's magnetic field is not just a map for travelers, it is a shield. Beyond our atmosphere lies the sun, a raging furnace of nuclear fusion that is constantly screaming into the void. It emits the solar wind, a relentless stream of high-energy charged particles traveling at 1,000,000 miles per hour. Without a protector, this solar gale would strip away our atmosphere and scour the surface of the Earth until it was as dead and dry as Mars. Our magnetic field is that protector. It forms a vast, teardrop-shaped bubble called the magnetosphere. When the solar wind hits this bubble, it is deflected, forced to flow around the Earth like water around the prow of a ship. Most of us will never see this battle, but it happens every second of every day. Occasionally, during a solar storm, these particles find a way in, spiraling down the magnetic field lines toward the poles. This is the origin of the aurora borealis and the aurora australis, the northern and southern lights. For the bird flying through the Arctic night, the aurora is more than just a beautiful light show. It is a visual manifestation of the very forces it uses to navigate. Imagine the bird's vision as it approaches the pole. While we see shifting curtains of green and purple light, the bird might see a surge in the intensity of its magnetic HUD. The sky is literally glowing with the energy of the shield that allows life to exist. The bird is flying through the front line of a cosmic war between the sun and the earth, guided by the very armor that keeps us all safe. To a human with a simple compass, north is just a direction on a flat map. But to a creature with a quantum eye, the magnetic field is three-dimensional. This is the secret of magnetic dip, or inclination. Near the magnetic equator, the lines of force run parallel to the ground. But as you move toward the poles, the lines begin to tilt, diving deeper and deeper into the earth until, at the poles themselves, they point straight down. This is why the bird's compass is so much more sophisticated than ours. It doesn't just know which way north is, it knows exactly how far north it is based on the angle of the magnetic field. This is its latitude. It is like having a built-in sextant that reads the invisible geometry of the planet. As the bird migrates from the northern hemisphere to the southern, it experiences a flip. It crosses the equator, where the field lines are flat, and suddenly, the dip begins to point in the opposite direction. For a long time, scientists wondered how birds handled this transition. Did they get confused? Did they spin in circles? The answer is another testament to the brilliance of the avian brain. The bird's quantum processor, cluster N, is programmed to recognize the dip rather than the polarity. It doesn't care about positive or negative. It cares about the angle. It follows the steepness of the lines, trusting the geometry of the Earth to guide it across the invisible hump of the equator. As you move toward the deeper stages of sleep, imagine the Earth as a giant glowing orb of magnetic lines. Imagine yourself floating within this field, protected by the magnetosphere, anchored by the iron core, and guided by a geometry that is as old as the world itself. You are not just a passenger on a rock. You are a participant in a vast electromagnetic symphony. As you descend further into the quiet of the night, we must confront a startling truth. The map the bird reads is not a static one. To our human eyes, north is a fixed point, an eternal anchor at the top of the globe. But in the eyes of the Earth's core, north is a moving target. This is the phenomenon of magnetic drift, a slow and restless migration of the magnetic poles themselves. Deep within the liquid iron core, the churning currents shift and eddy like the currents of a vast metallic ocean. These internal storms cause the magnetic North Pole to wander across the Arctic landscape. Since it was first formally located in 1831, the magnetic North Pole has traveled over 1,400 miles, moving from the Canadian Arctic towards Siberia. In recent years, this movement has accelerated, reaching speeds of over 30 miles per year. Imagine the challenge for a migratory bird whose entire survival depends on a quantum compass calibrated to a shifting target. If the bird's internal map were rigid, a drift of 1,000 miles would be a death sentence, leading the bird into the middle of the ocean rather than the safety of its breeding grounds. But the bird's system is not rigid. It is a masterpiece of dynamic recalibration. Every year, as the bird prepares for its journey, it doesn't just rely on the factory settings of its DNA. It performs what scientists call a compass calibration. During the twilight hours, as the sun dips below the horizon and the stars begin to emerge, the bird compares its quantum magnetic sense with the celestial map above. It uses the rotation of the stars and the polarization of the light to check the magnetic north. Think of it as a software update for the soul. The bird realizes that the magnetic pull has shifted slightly to the east or west since the previous year, and it adjusts its internal heading accordingly. This ability to cross-reference multiple senses to use the stars to correct the magnetosphere is one of the highest forms of biological intelligence. It is a continuous dialogue between the sky, the earth, and the eye. But there is a grander, more dramatic event hidden in the Earth's history: the geomagnetic reversal. Every few 100,000 years, the Earth's magnetic field doesn't just drift, it flips entirely. North becomes south, and south becomes north. This process can take thousands of years, during which the magnetic shield grows weak and chaotic, sprouting multiple mini-poles across the planet. We are currently overdue for such a reversal. The Earth's magnetic field has weakened by about 10% over the last 2 centuries. For a creature that navigates by the quantum flicker of an electron, a reversal is a cosmic crisis. Yet, fossil records show that migratory species have survived dozens of these flips over millions of years. How did they endure the chaos of a collapsing shield? They relied on the redundancy of life. Because the bird has a multimodal navigation system, part star chart, part sun compass, part infrasound map, it can survive even when the primary magnetic signal becomes a jumbled mess. It leans more heavily on the ancient memory of the stars until the Earth's iron heart settles into its new orientation. As you lie in the stillness, consider the resilience of this connection. The Earth is a living, breathing entity of magnetism, constantly shifting and reforming its invisible skin. And the bird is its dancing partner, always adjusting, always listening, always finding its way through a world that refuses to stand still. You, too, are part of this resilience. Your body, your rhythm, and your sleep are all anchored to a planet that is slowly, majestically turning its face to the stars. To reach the deepest level of this journey, we must listen to the Earth. If we could translate the magnetic field into sound, it would not be a silence. It would be a profound, low-frequency hum, a cosmic cello vibrating at the very limits of perception. This is the music of the geodynamo, the sound of billions of tons of molten metal rushing past the solid inner core. This hum is what the bird hears with its entire being. While the eye provides the direction, the body provides the resonance. Some scientists believe that the magnetic field might even interact with a bird's inner ear, or perhaps with specialized cells in its nervous system that we have yet to fully map. It is a whole-body navigation. Imagine the bird suspended in the air, miles above the dark Earth. It is not just looking at a map. It is vibrating in sympathy with the planet. It is tuned to the frequency of the Earth. When the bird is on course, there is a sense of harmony, a biological click where the internal rhythm matches the external field. When it drifts off course, the harmony breaks, creating a subtle, instinctive tension that pulls the bird back toward the center of the line. As you drift closer to sleep, try to imagine this hum within yourself. Feel the steady, heavy rotation of the Earth beneath you. You are held in place by the same gravity that keeps the moon in orbit, and you are bathed in the same magnetic field that guides the turn. There is a great, invisible peace in this alignment. You don't need to find your way. The world is already carrying you. The bird in the sky is a reminder that we are never truly lost. We are inhabitants of a planet that provides every tool we need for the journey. Whether it is the quantum flicker in a robin's eye or the deep iron heartbeat of the core, the universe is always whispering the way home. All we have to do is listen, breathe, and let the magnetic tide carry us into the night. As the natural hum of the Earth's core continues to vibrate beneath you, we must now address a new artificial layer that has been draped over our planet in the blink of an eye. For millions of years, the electromagnetic environment of Earth was silent, broken only by the crackle of lightning or the occasional flare of a solar storm. But in the last century, and especially in the last few decades, humanity has ignited a digital sun that never sets. We live in a world of invisible smog. Every time you send a text, every time a satellite beams a signal to a receiver, every time a high-voltage power line hums with the energy of a city, we are adding to the electromagnetic fog. To our human eyes, the night sky over a city looks clear, save for the orange glow of streetlights. But To a creature with a quantum eye, the modern city is a blinding, chaotic storm of interference. Imagine a bird approaching a metropolitan area. In the distance, it sees the steady, reliable blue of the north. But as it gets closer, that signal begins to flicker. The air is thick with radio frequency noise, Wi-Fi, cellular data, television broadcasts, all vibrating at frequencies that overlap with the delicate dance of the electrons in the bird's eye. This is not just noise. It is a direct assault on the quantum state. Scientists have conducted startling experiments to understand this interference. They found that even the weakest radio frequency field signals thousands of times weaker than the one emitted by your mobile phone can completely disable a bird's magnetic compass. Why is this? It goes back to the radical pair we discussed earlier. Those two entangled electrons dancing in the cryptochrome protein are in a state of exquisite, fragile balance. They are waiting for the gentle nudge of the Earth's magnetic field. But the high-frequency oscillation of man-made radio waves is like a sledgehammer hitting a spinning top. It forces the electrons to decohere, to lose their quantum connection before the Earth has a chance to tell them which way is north. In a laboratory in Oldenburg, Germany, researchers found that robins kept in wooden huts were unable to orient themselves because of the electronic background noise of the nearby university. But when they covered the huts with grounded aluminum plates, creating a Faraday cage that blocked the man-made noise, the birds instantly regained their ability to find north. Think of the tragedy of this digital wall. The bird has the hardware, it has the ancient map, and it has the will to fly. But the very air we have filled with our data is acting as a blindfold. As you lie in your room, surrounded by the invisible signals of your own technology, consider the silent struggle of the traveler above your roof, trying to find a single, pure note of the Earth's music in a world that has become incredibly loud. The interference is not just electromagnetic, it is also visual. Many migratory birds are nocturnal travelers. They fly at night because the air is cooler, the winds are calmer, and the predators are few. They have evolved to navigate by the stars, the stellar compass, using the rotation of the night sky around the North Star as a permanent anchor. But modern cities have erased the stars. The phenomenon of sky glow, the scattering of artificial light in the atmosphere, creates a dome of brightness that can be seen for 100 miles. For a bird, this light is a siren's call. They are evolutionarily programmed to fly toward light, which in nature usually means the horizon or the moon. In the modern world, it means the glowing glass of a skyscraper. Every year, millions of birds are lost to fatal light attraction. They become trapped in the beams of city lights, circling in exhaustion until they collapse or collide with buildings. Their cluster N processors are overwhelmed by the sensory conflict. The magnetic field says fly one way, but the overwhelming visual stimulus pulls them another. This is the sensory conflict of the 21st century. It is a world where the ancient and the modern are in a state of constant, quiet collision. But even in this fog, there is hope. We are beginning to realize that by simply dimming the lights during peak migration weeks, or by shifting our communication frequencies away from the sensitive quantum windows of biology, we can clear the path for the travelers of the sky. Despite the fog, the migration continues. Life is not a static thing. It is a relentless, adaptive force. Birds are already beginning to adjust to the digital age. Scientists have observed that some species are relying more heavily on their backup systems, their olfactory maps of smells, and their infrasound maps of the landscape to navigate through the most polluted electromagnetic zones. There is a profound resilience in the avian brain. It is as if the birds are learning to filter the noise, seeking out the gaps in our radio frequency chatter. They are the first inhabitants of the hybrid Earth, creatures that must navigate a world that is part biological and part electronic. As you drift toward the final stages of sleep, let the image of the bird in the fog be a lesson in perseverance. The traveler does not stop because the way is difficult. It does not turn back because the stars are hidden. It trusts in the internal flicker, the ancient memory, and the steady pulse of the planet that survives beneath the noise. You too are navigating a world of constant information, of digital noise and glowing screens. But beneath it all, your own biological rhythms, the rise and fall of your breath, the steady beat of your heart, remain anchored to the deeper, slower cycles of the earth. Like the bird, you can find the silence within the noise. You can find the way home as you drift now into the deepest reaches of the night, where the boundaries between the physical world and the world of dreams begin to blur. We must contemplate the profound revolution this tiny bird has ignited in the halls of human science. For centuries, we built a wall, a high, iron wall between the wet world of biology and the cold world of physics. We believed that life was too messy, too warm, and too chaotic for the delicate, ghostly laws of quantum mechanics to apply. We thought that quantum effects were reserved for the sterile vacuum of a laboratory, occurring only at temperatures near absolute zero. But the robin, with its pulsing heart and its fluttering wings, has torn that wall down. The discovery of the quantum compass in the Avian eye is more than just a biological curiosity. It is a fundamental shift in our understanding of what life is. It has birthed a new frontier, quantum biology. This field suggests that life does not just tolerate the strange laws of the subatomic world, it exploits them. It suggests that evolution over billions of years has found ways to maintain quantum coherence, that fragile, spooky connection, in environments where human engineers still fail. This realization is forcing us to redefine the machine of life. We are not just heat engines or chemical processors. We are quantum machines. The bird's eye is a living proof that nature is a far more sophisticated engineer than we ever imagined. It tells us that the spooky action at a distance that Einstein feared is not a laboratory fluke. It is a survival strategy. It is the very fabric of the living world. What does this mean for us? For you, lying there in the silence? And for the future of our species? The lessons learned from the bird's eye are already beginning to ripple into the world of human medicine and technology. If a bird can maintain a quantum state in a warm, wet eye, then we can learn how to do the same. This is the holy grail of quantum computing. Currently, our most powerful quantum computers require massive cooling systems to keep their processors at temperatures colder than deep space. But by studying the molecular cages of the cryptochrome protein, we are learning how to build warm quantum sensors. Imagine a future where medical imaging does not require giant, freezing MRI machines. Imagine tiny quantum sensors inspired by the bird's eye that can detect the faintest magnetic signatures of a single cancer cell or the subtle electrical whispers of a thought forming in the brain. We are moving toward a world of quantum medicine, where we can diagnose and heal at the level of the electron's spin. But the implications go even deeper, into the very nature of human perception. We now know that humans also possess cryptochrome in our retinas. While we may have lost the conscious ability to see the magnetic field, the hardware is still there. Experiments have shown that under certain conditions, human cells can respond to magnetic fluctuations. Are we, perhaps, sleeping navigators? Is there a dormant sense within us? A forgotten connection to the Earth's magnetic pulse that we simply no longer know how to listen to? By studying the bird, we are rediscovering a part of our own ancestry. We are realizing that we are more connected to the planetary field than our modern digital lives allow us to feel. The bird's journey also offers a profound philosophical shift. In the 20th century, we often viewed the universe as a collection of separate objects, individual animals, individual planets, individual atoms. But quantum entanglement teaches us that separation is, in many ways, an illusion. When two electrons are entangled in a bird's eye, they are one, regardless of the distance between them. When that bird responds to the magnetic field generated by the Earth's core thousands of miles below, it is participating in a vast, interconnected system. There is no bird and Earth as separate entities. There is only the bird-Earth system. This is the quantum ecosystem. It suggests that the health of the planet and the health of the individual are inextricably linked at the subatomic level. When we disrupt the Earth's magnetic environment with our technology, we aren't just interfering with a bird. We are tearing the fabric of a quantum connection that has existed for eons. As you breathe in the dark, consider this unity. You are not an island. You are not a lonely observer in a cold universe. You are entangled. You are linked to the iron core beneath you, to the stars above you, and to every living thing that shares this magnetic shield. The bird in the sky is a messenger of this unity. It flies through the night to tell us that we are all part of a single, pulsing quantum whole. Looking forward, the lessons of the feather promise a revolution in how we power our world. One of the greatest mysteries in biology is photosynthesis, how plants turn sunlight into energy with nearly 100% efficiency. We now know that plants use quantum walks to transport energy across their cells, ensuring that not a single photon is wasted. By combining what we know about bird navigation and plant energy, we are designing a new generation of bio-inspired quantum technology. We are looking at solar panels that mimic the quantum efficiency of a leaf, and navigation systems for our own deep space probes that mimic the quantum eye of the Tern. We are even exploring the possibility that consciousness itself might have a quantum origin. Some theorists suggest that the flash of insight or the feeling of intuition might be the result of quantum processes in the brain's microtubules, similar to the processes in cluster N. While this remains a frontier of speculation, the bird has taught us one thing: never bet against the impossible when it comes to life. The future of humanity may not be written in silicon and steel, but in the delicate, flickering logic of the quantum world. We are learning to speak the language of the electron, a language that the birds have been speaking since before the first dinosaur walked the earth. And so, we return to the bird, still flying, still dreaming, still guided by the invisible. The 120-minute journey we have taken tonight from the frozen tundra to the molten core, from the ink-stained funnels of Frankfurt to the spooky entanglement of the subatomic world, comes to its rest here. The bird has found its way. It has crossed the oceans and the deserts. It has navigated the digital fog and the magnetic silence. And now, it is descending. It finds that specific tree, that specific branch, that specific home. The quantum dance in its eye slows. The triplet states and singlet states settle into a quiet, chemical peace. You too are descending. Your journey through the world of information and wonder is coming to a close. The quantum HUD of your own mind is fading, replaced by the soft, warm darkness of deep sleep. You have explored the architecture of the invisible, and you have seen that the universe is a place of profound order and hidden beauty. There is no need to navigate anymore. There is no need to search. The Earth is holding you in its magnetic embrace. The core is humming its low-frequency lullaby. The shield is up. The stars are in their places, and the quantum ghosts have finished their dance. The bird is at rest. The world is at rest. And you, a traveler of the quantum world, are finally, truly home. As the last echoes of the geodynamo fade into the silence of your room, let go of the thread. Let the magnetic tide carry you away, into the dream, into the deep, into the night.